Hello accounts and BTEC people. So we're going to have a look at break-even analysis. So break-even is part of a family of analysis tools, CPV analysis, the relationship between cost, profit and volume, sometimes just referred to as short-term decision making. So I'm going to take you through break-even calculations, adding a target profit to them, then work out the margin of safety, draw a graph, do a quick check question, then after about 8.5 minutes we should be on to the more complicated contribution to sales ratio, which is more useful in the real world than the break-even formula, then changing the formula around to do a specific type of question, and then using the goal seek to shortcut some of the mathematics on the what if type calculations and goal seeks in a spreadsheet formula. So let's have a look then. I've already mentioned it's part of the CPV, so it gives us an insight to the minimum sales or volume, whether it's bought and sold or made and sold, required to start making a profit. It's a limited analysis tool because the nature of the selling price, we're having to sell at a single price, variable cost has to be constant, fixed cost have to be predictable. So the answer's a rough guide, it's not the perfect number. But you wouldn't want to start a new business without doing it. So the standard formula has the fixed cost divided by the contribution, which is the selling price minus the variable cost. Each of those would be per unit, and it gives us the break-even volume or point in units. The additional formula, if we were leaving a day job and therefore we need to cover some bills, we need to add the target profit to the fixed cost, it will of course give a bigger answer. So let's have a go at some numbers. So the first break even, we've got fixed cost, selling price, variable cost and target profit. So golden rule, break even points are always rounded up to the next unit. If they're rounded down, we'd make a loss. That's the fixed cost divided by the selling price minus the variable cost, and then rounded up to 0 decimal places, a whole number. So if we made and sold 1938 units, we'd be making a tiny profit. 1937, if it rounded down, we'd make a loss. So this is a very similar formula. Put in another bracket because I've got to add the target profit to the fixed before I divide by the contribution. But apart from that, it's the same. So if I made and sold 3,783 units, I'd make a profit of £10,000. So the margin of safety is exactly as it says, difference between planned and expected or budgeted, predicted sales, and the break-even point. So if we expect to sell 2,000 units, all I've got to do is take off our break-even point and 62 units, or I could lose 62 units and still not make a loss. I can also do as a percentage of our prediction of our budget. I've already formatted it as a percentage, so no times 100, 3%. And then in pound signs, £619.38 worth of sales. So let's have a look at a graph. So this is the frameworks there. The data is here. So we've got fixed cost, variable cost and revenue to work with, and we just need to copy them in. I'm copying them in the proper way so that if we needed to change something or if something changed on us, we can see the effects. Now, $sign in front of the B in the formula means that when I go across, it stays absolute as B. It's still B, still B, which it should do because fixed costs are the same whatever volume. The variable cost, well, we're in the column for 0 units, so it will come out as 0. If I don't make anything, I don't use any materials or anything, and again put the dollar sign in. I'll copy that one across with the other rows at the bottom. Total cost 150,000. Revenue will also be 0 because I haven't sold anything. Dollar sign. And this doesn't need a dollar sign. It's the profit. The profit is the revenue minus the costs. Not really needed for a break-even graph, but useful in a question, or you would put it in a table for somebody. So what you can see happening is we're making a loss, then we hit break-even point, and then we start to make some money. So let's turn it into a graph. Let's have a look. We'll move it into a new sheet because then it's easier to work on. It always needs a title. It needs a very minimalistic one. And we also need to change this. See the zeros there? It always comes up like that. Hover over the axis. When it comes up horizontal category axis, right click, format the axis, and on a tick mark. There we are, got the right bullet point. And you'll see the zeros gone, so we've got a proper origin now. And we've got two items we don't need. We don't need to have the variable cost line on our break-even chart, and this is actually a PV line, profit volume line, a separate chart we draw or create, and that doesn't belong on there anyway. So now we've got our proper break-even chart. You can see where revenue hits cost was the 10,000. We knew that from the numbers, and we can also see that it was £400,000 in terms of sales. So that's our chart done. So back to some numbers then. So quickly cap. So our break even is our fixed cost, £2,000 here, divided by our contribution, or 60 minus 10. I'm going to take a shortcut. We could do that in revenue. So you could be asked for the break even with a pound sign in front of it in revenue. So the break even point is £2,400 worth of sales. And then our margin of safety, that's our expected units minus the break even. In terms of revenue, and if I do the break even divided by the budget, it gives me 33%, or 33.33. I couldn't be bothered to show all the other decimal places. We can make it as many as we want. And then our target profit, all I've got to do is take my fixed cost, add my target profit to it, and divide that by the contribution. There we are. So actually our expected sales hit our target profit. So that's the basics done. Let's have a look at some additional work that we can do around the CPV break-even formulas. So this is the contribution to sales ratio, the one that's a little bit more useful. Uses fixed costs over the contribution as a decimal, gives us an answer in pounds. So we use it far more often in the real world than the break-even formula. For an example like this, where a student of mine was running a hair extension stall in a market when she wasn't in college. Everything she sold at different prices, so that's why the standard formula didn't work. But fortunately, she had a very simple formula: double the cost, 100% markup, or 50% margin. So something that cost her 10, she sold for 20, bought for 3, sold for 6. So that means the contribution is actually constant as a percentage. So for the bottom one, 3 divided by 6, it's 50% contribution. And that means, as a decimal, 0.5. So once we've got her fixed costs worked out at 90, we can use the formula and come up with our answers. So actually, if we do the 90 divided by contribution to sales ratio as a decimal, it means that anything more than £180 sales in a day, she's making a profit. And if you wanted to give her £35 extra or more of a target, £250 a day, and she's hit her target profit. It's worth getting out of bed and going to run her store. So the rest of the functions then, we're going to use the formula backwards or forwards or just manipulate it. We're going to use the same numbers as we've used here, the same target profit, the same selling price, etc. And we've already worked out that the break even for target profit is 3783. So if we could sell 4,500 units, could we reduce the price? Well, that's the standard formula. Top line divided by bottom line equals this. Top line divided by this equals the bottom line, which is what we've done here. So actually, fixed cost plus target profit over break even equals the contribution. So if we do our target profit plus our fixed cost and divide that by our volume that we think we can sell, what we now know is that we need to make £4.56 contribution per item. And if we add that to our variable cost, we've got a selling price which is where we would expect it to be, £9.13. We're above the 3783. So what this is now telling us is that if we sold at £9.13, we would break even at 4,500 units with a target profit of 10,000. And then we can use the goal seek as well. So to use the goal seek, we've actually got to go back to the original formula. But now, instead of typing in 10,500, I've got to use the cell reference, otherwise it won't work. Now I haven't rounded it up yet. That's what it would look like unrounded, because an option is, instead of typing it in or even using the function wizard, in fact I nearly left it at round, is to type it in afterwards. And now we're back to where we were. So now I'm saying, can I change the price? It's going to have to go up to break even at 1750 units. Well, it could take me a couple of hours to calculate it manually, bit of test, or I can ask a spreadsheet to do it in seconds, because the goal seek function says that if I want to change the 1938 to 1750 by changing the price, I can, and it works it out that quick. So if the selling price was £10.57, I would break even at 1750 units. So back to where we were. I could also do how much do I need to reduce the costs to break even at 1750 units. So I could increase the price or reduce the cost to break even at 1750 units. So back to our goal seek. It's still 1750, but I'm going to change the fixed costs. So in other words, can I trim my fixed costs? Well, if I can trim them by just over £1,000 to 9,480, I can still break even at 1750 units. I could also do a similar sum with the variable costs to negotiate with the supplier of a component or something, and know where I stand. So there we are. We've done the break-even formulas and we've applied it in lots of different ways, quite versatile, and we've also seen the CSR ratio.